All right, welcome back for our last lesson in chapter 4. So here we're going to formalize relations and functions. So we got some keywords. A relation is any set of ordered pairs. Domain are our input values. Range are output values. We have a vertical line test, which is better if we just do it. And then function notation is a way that we can write a rule. Instead of using y, we'll use the symbol f of x, or actually any letter with our x in parentheses. All right, which just is read function at x. Okay, so key concept, we need to remember that a function is the pair of one output with exactly one input. So each input can only have one output. And that means that x cannot cheat on y. That's the quickest way I can think of to help you guys remember it. That's how I used to bring it up with my high schoolers. Our x value can only have one y value. If our x value has two y values, then it's cheating and it's not a function. So, all right, so example 1, identifying functions using mapping diagrams. So we're going to identify the domain and range of each relation, represent the relation with a mapping diagram, and then we're going to answer the question, is it a function? So starting off with the domain. So the domain are our input values. That's our x values. So that's going to be the -2, the 0, the 4, and the 5. Those are our domains, -2, 0, 4, 5. Our range is going to be the 0.5, 2.5, 6.5, and then we don't have to write a number twice. We do have 2.5s, so we'll just write them once. So that's our domain, that's our range. Now, mapping diagram. That's where we write our domain in numerical order. And then most of the time it's like in an oval shape. And then we write our range in its own little oval. And then mapping just means that we're taking our input and mapping it to its output. So this first point was -2, 0.5. So I'm going to draw an arrow from -2 to 0.5, from 0 to 2.5, from 4 to 6.5, and then from 5 to 2.5. Now, the next thing is this relation a function? Well, the definition of a function is for every input, there's exactly one output. So each of our inputs maps to only one output. So this is a function. And again, even I know that we're like, but there's two 2.5s. Well, that's our output. Our output can have multiple inputs, but our input can only have one output. All right, so now we're going to move on to the next one. Our domain, we want those x values. I tend to put them in numerical order. So 4, 5, and then 6. So 4, 5, and then we have those two 6s. All right, and then our range, again, in numerical order, 3, 4, 5, and 8 is our range, because those are the y values. So this is x, and this is y. Always. That is always the case. And so then I'm going to put my domain, 4, 5, and 6, into a little oval, and my range, 3, 4, 5, 8, in an oval, and then I'm going to map it. So 4 mapped to 3 because it was 4, 3. 6 maps, no, don't end. 6 maps to 5 because 6, 5. 6 maps to 4 because 6, 4. And then 5 maps to 8. Now, is this one a function? And this is not a function. Why? Because 6 cheats on 4 with 5, or 6 cheats on 5 with 4. Either way, the 6 has 2 output values, and that makes it not a function. Our x value can only have one y value. All right, so to be a function, for every x, there is only one y value. For each, to not be a function means that an x has multiple y's. So that's just think about that. All right, so now we want to identify functions using the vertical line test. So the first thing you're going to do is you're going to graph all of these points, right? And then like over here for B, we're going to create a table x comma y. I'm going to pause the recording because you don't need to see me stumble through all that graphing. And I'm going to graph these, and then I'll come back. So you're probably going to have to pause or want to pause so that you yourself can graph them as well. All right, so we're back. So I graphed our points, and then I created a table using x values -2, 0, and 2. You really could use any x values you wanted, and these are the two graphs that we have. So now it wants to know whether it is a function or not using the vertical line test. Now, the vertical line test is just a way to check visually if we have multiple x values or multiple y values with the same x value. So basically I am just imagining vertical lines, and if you're doing this on your Math Excel, I would take your pencil and just run it vertically across your graph. But I'm running these vertical lines, which are technically already there, running these vertical lines, and as long as they only cross a point, one point on the graph, each line crosses only one point, then it's a function. Now, in this first one, this line, vertical line right here, crosses 2 points. And really, I could have stopped right then and there the moment it crossed 2 points, because it doesn't matter if it only crosses 2 points, and it doesn't have to cross multiple points each time I draw a line. The moment one line crosses my graph more than once makes this not a function. And so what does that mean? Well, when we look at these, I had -4 here, and I have -4 here with different y values, which means our -4, our x value, is cheating on our y's, and for every x, there's only one y. So then when I come over here and I do my vertical lines the best of my ability, right? My lines are only crossing that graph in one spot. And so that's what makes this a function. So what does that mean? For every x value, there is only one y value. I don't have two -2's, right? -2 is only going to equal -1. It's not going to equal anything else. And that's what makes this pass the vertical line test. So this is a function, and this one's not a function. All right, in the next video, we are going to talk about evaluating functions and then finding domains and ranges given different types of information. So I'll see you there.